Hello, today I received a shipment with a large round LCD display from Elecrow. The device is packed in two separate boxes so that it is fully protected from damage during transportation. Inside there is a display, USB cable for powering and communication, as well as an additional cable for connecting an external module. This is CrowPanel 2.1-inch HMI ESP32 rotary display for 480 on 480, which has some really impressive features. High performance ESP32 S3 chip, Wi-Fi and low power Bluetooth, capacitive touchscreen with knob, and a rotary encoder in the form of a circular ring. It supports Arduino IDE, Lua RTOS, Home Assistant, Platformio, MicroPython and LVGL library. When the device is turned on for the first time, a demo application is installed that presents several basic features on the display. Thanks to the high resolution, the image and screen quality, the image on the display is clear and beautifully visible from all angles. This time I decided to make a relatively simple project without the proposed support from Elecrow in order to discover the way to connect all the components to the microcontroller. At first I tried to use the TFT ESPI library, but soon I discovered that the display communicates via RGB panel interface, IA parallel RGB and not SPI, so this idea was dropped. So I decided to use the Arduino GFX library, which has support for this way of connecting the display. I imagined the project to be made in a classic way without the support of LVGL library and Squareline Studio, but manually driving all the lines individually. This way the project will now look like most projects that use the previous mentioned libraries and tools, and will therefore be authentic. The choice is another clock project in addition to my large collection of unusual clocks. This time it will be a visually interesting clock, actually a radar simulation on which the exact time and date will be written. In this project I will present the functionality of the Wi-Fi part as well as the rotary encoder. First let's see the device functions in real conditions. After turning on the device, a message appears on the screen and then the clock connects to the Wi-Fi network. After that the main screen appears. The default color is green, as in the most real radar systems. The upper half of the screen shows the time and the lower half shows the date. The exact time is downloaded via internet from NTP server, so there is not need to manually set the clock. Next, to demonstrate the functionality of the rotary encoder, I added a section in the code where the colors of the radar can be changed. At the beginning of the code, 5 color schemes are defined that change by turning the encoder. The color changes instantly and does not affect the functionality at all. This is the red scheme, then the blue pattern, next is yellow-orange pattern, and white pattern. Now a few words about the code. When compiling, I used ESP32 Core 3.x.x, the latest version of Arduino GFX library, and Arduino IDE version 2.3.6. Overall, the code may not be very simple, which is a consequence of the fact that everything is drawn programmatically. However, it is made in a way that you can easily change several parameters to make a custom clock phase. It is also seen that the code uses a minimum number of basic libraries. I plan to create code in the next project with this display using the new libraries and tools developed specifically for projects with LCD displays, because the development is much easier and the final effect is fascinating. Also, I made a kind of housing for this project from 3 and 5 mm PVC material coated with colored silt adhesive wallpaper. And finally, a short conclusion. This module from Elecrow has endless possibilities for making do-it-yourself project in a relatively simple way, using specialized libraries and tools, which way I will describe in more detail in one of the following videos. A huge advantage is the fact that there is no need for soldering or other hardware work. There is even a cable for connecting external modules, also without soldering during the test period.